continuing the question. So over here we have water, we have copper, and we have ice. So water, let's write over here mass, 200 grams of water, and let's write over here initial temperature, final temperature, change in temperature, specific heat capacity, latent heat. So 200 grams of it's 250 grams. 250 grams of water, and it is given to be 30 degrees Celsius, is contained in a copper vessel of mass 50. So water is contained in the copper vessel, so both will have same temperature, and we have to calculate the mass of ice. Okay, so nothing is given, so ice to be taken as 0. So here it says the final temperature should turn to 5 degrees Celsius. Okay, so basically you'll have a calorimeter. Inside that there is water, and when you add ice to it, the final temperature is 5 degree. That means the ice will also melt and become water at 5 degree. Water itself, which was at 30 degree, will come up to 5 degree. So this is 25, this is 25, and this is 5. Okay, like I told you again, we are not considering it to be negative, it is positive. Then specific heat capacity of water to be 4200 joule per kg per Kelvin. For copper, it is 400 joule per kg per Kelvin. Ice will have heat capacity, latent heat, that is 336 joule per gram per Kelvin. Okay, so we need this M. Now we are going to write down the statement that we had written earlier for the earlier exercise. When no heat is lost to the surrounding, the heat lost by hot body is equal to the heat gained by cold body. So we are going to write down that statement. Remember, in the exam, there are no marks for writing that statement unless they ask you questions like what is the assumption that you have made. Okay, so unless they ask something like that, there are no marks. But if you don't write, then you lose marks. Okay, so over here, these are hot bodies, they are losing heat, and ice is the cold body that is gaining heat. So one side of the equation you will have hot body and one side the cold body. So you will have M1 C1 delta T1 plus M2 C2 delta T2. So this is for water, this is for copper, and on the other side you have ice. So ice is going to melt first, and then the temperature is going to rise to 5 degree. Okay, so this is your knowledge to come to this equation, because solving after that is easy. So this is 250 into 4.2 into 25, and this is 50 into 0.4 into 25. Again, I'm repeating, this is gram and this is kilogram. So therefore you have to be careful when you're substituting. This is M into 336. This is M into 4.2 into 5. Remember, this will be for water because now it is no longer ice, it has turned into water. Okay, so I can take 50 common, I can take 25 common. So this will be 5 into 4.2, and this is plus 0.4, and this is M common, that is 336 plus 21. Okay, 50 into 25, and this will be 4 into 4, 5 into 4.2, that is 21, plus 0.4, that is 21.4. And this is M into 357. Okay, I suggest that when you keep something like this, if it becomes easier to reduce, okay, rather than just multiplying, getting a bigger number and then again dividing. So here, and I also again ask you to do the calculation yourself and avoid using calculators, because in the exam you're not going to get one. Now, sometimes these textbook numericals have values which do not end up in a integer, so that may be a problem. Hopefully, like in the board exam, the questions are such that the numbers are easier to get. Okay, because the objective is not to test how good you can divide numbers. The objective is to test this. Okay, so the marks are awarded for writing this statement and equating them, and then to get the correct answer. This information writing will not give you marks, but I hope you agree that by representing it in this way, it becomes easier for you to frame this equation. Okay, any questions you have?
No, sir.
This is 2 kg of ice, and the ice will be at 0 degree. Again, if we can write it like this, we have ice over here, we have water over here. Mass is 2 kilogram. Initial temperature will be 0 degree Celsius, and water is 100 degrees Celsius. What mass of water is added? Now here the question is, you have to just imply a few things. 2 kg of ice melts when water at 100 degrees poured in a hole drilled in the block of ice. So therefore, here we have to assume that it is 0 degree Celsius is the final temperature, because ice is melting and then it is not rising it to any other temperature. Okay, so basically ice melts and water temperature will also from 100 degree will drop to 0, because you can't have ice and water at different temperatures in a mixture, okay, as a final state. So therefore we will get M into L is MC delta T. So 2 kg, and this is 336,000. And here we have M into 4,200 into 100. Please make sure that you have the units proper. So this is M, this is 2,336, 3 zeros, 4,200 and 100. So 1, 2, 3, 1, 2, 3. Okay, so this will give you 1.6 kilograms. Okay, also important is the answer statement, that 1 kg of the mass of water is 1.6 kg. Okay, moving ahead, the next question is, calculate the total amount of heat energy required to convert 100 grams of ice at -10 to water at 100 degrees Celsius. Okay, so you have, this is relatively easier question than what we have done till now. So 100 grams of water sorry, ice, which is at -10 degrees Celsius, and you have to bring it to 100 grams of water at 100 degrees Celsius. So you know the steps. Okay, you will require mc delta t to take ice at -10 to 0. Then you will need to melt that ice, and then you need to take the ice to 100 degrees. So this will be 100 into 2.1 into 10 plus 100 into 336, 100 into 4.2 into 100. Make the calculation easier. You take the 100 out, 21, 336, and this is 420. So 420, 336, and 21. So this will be 7 and 7. So 77700 joules, which can be written as 7.77. You're taking 1, 2, 3, 4, 10 to the power 4 joules. Okay, this is question number 10. This question has two parts. So in the first part, mass is 200 gram, and this is ice. So the temperature is 0 degree, and it converts to 0 degree water. Okay, and the time taken is 1 minute equal to 60 seconds. So we know that it is melting process, so it is m into L, and this is power into time. So power into 60 is 200 into 336. Okay, 6 5s are 30. So this will be 56 into 20. 1120 watt will be the power. Now this is used in the second half of the question. It says that now that you have 200 grams of water at 0 degrees Celsius, how long will it take to bring it to 20 degree water? Okay, so how long will it take to bring it to 20 degree water? So again, over here we have Q equal to mc delta T in this point, which is P into T is mc delta T. So 1120 into T is 200 into 4.2 into 20. So 200 into 4.2 into 20 and 1120. Okay, so this can be reduced further. And this will be 15. The answer is 15 seconds. Okay, so the first information which is this, gave us the value of power of the cooler. In this case, sorry, it is a heater. So, and then they are asking you the time that it will take to bring water to 0 degree, 20 degrees Celsius. So these are the numericals. We'll be sharing more in a separate assignment.